Hi everyone, welcome to Leetcode programming. In this video, I would like to discuss about the problem partitioning into minimum number of Deci-Binary numbers. So this is a problem from today's weekly challenge, and as you can see, this is a medium level problem. So let's look at the problem. A decimal number is called a Deci-Binary if each of its digits is either 0 or 1 without any leading zeros. For example, 101 and 1100 are Deci-Binary while 112 and 3001 are not. So we are going to consider numbers with digits from binary system, but the value of the number will be decimal only. So that way 112 is a decimal number, but it is not a Deci-Binary because we are using 2 here. So 2 is not from the binary system. Similarly, 3 is not from the binary system, so this is not a Deci-Binary number. So given a string n that represents a positive decimal integer, return the minimum number of positive Deci-Binary numbers needed so that they sum up to n. Let's look at examples so it will be more clear. So we have a string 32, that means it is equal to a value of integer 32. So we need 3 Deci-Binary numbers, so namely 10, 11, 11. So these 3 add up to 32. So we need to remember that even though we use binary digits here, the value of the number remains intact. So it is not equal to 2 in binary. In binary system it is equal to 2, but here the value of 10 is still remains 10. It is not equal to 2. So this way we need 3 numbers to make 32. In the second example, we need such 8 Deci-Binary numbers to make 82734. Similarly, in the last example, we need 9 such numbers. And constraints are so the length of the string can go from 1 till 10 power 5, and n consists only of digits, and it doesn't contain any leading zeros. So given a string representing a number, we need to find the minimum number of Deci-Binary numbers that we need to make up that number. So it looks a bit it doesn't look like a straightforward approach, but let's look at examples so that we can get some insights. So let's take a simple example 2. So how many Deci-Binary numbers do we need to make 20, or how many Deci-Binary numbers we need to make a sum of 2? So let's start with 1 because we are only allowed to use 0 or 1. So we can put the problem this way. So how many operations we need to make 2 to 0, and in each operation we are allowed to use only Deci-Binary numbers. So after first operation, when we use 1, the remainder will be 1. Then in the second operation we can use one more 1, then the number becomes 0. So basically you need 2 Deci-Binary numbers or 2 operations to come up with the answer. Let's take one more example 32. So now we can use 11. So after 11, if you subtract 11 from 32, the remainder will be 21. Then after using one more 11, the remainder will become 10. Then after third operation, we can use 10, then it becomes 0. So basically we need 3 operations or 3 Deci-Binary numbers to make 32. So if you closely observe here the value is 2, so we need 2 operations. So the max digit here is 2, and you need 2 operations. Here we need max digit here is 3, and we need 3 operations. So to make 2 to 0, we use 2 operations. After 2 operations, 2 has become 0, whereas 3 has become 0 after 3 operations. So ideally the answer will be, you just have to find the max digit from the given string. So let's validate this insight using our examples. So we have n32 here, so 3 operations. Here the max digit is 8 and the answer is 8. Here the max digit is 9, so the answer is 9. So that works perfectly right. So let's write some code. Let's start with Java. So the answer will be initialize the answer to 0, and you go through every character as discussed. You just have to find the max digit. So for every character in that string, find maximum of answer and the current digit. So current digit you can get using c minus 0. Finally return the answer. So let's check. Yeah, it works fine. So let's submit and check. Yeah, 4 milliseconds and 100% faster. Let's quickly go through the C++ solution. It's again same. Yeah, so you just take answer initialize to 0 and go through every character and find the maximum. So you can as well replace this here. You don't have to use another variable. Then you just use max function, library function. So let's submit and check. Yeah, so let's check. Yeah, so 52 milliseconds and faster than 100% of all submissions. And as we discussed, we are just going through the string only once. So the time complexity here will be O of n because we are going through the string and every character. And there is no extra space. So space complexity will be O of 1 and time complexity will be O of n. That's it. Thanks for watching.